The topic of sampling distributions is one of the most important topics in the statistics class, but it's also one of those topics in which it's difficult to understand why it's important when you're first learning about it. The reason is because you have to understand the idea of a sampling distribution and all of the concepts that go along with sampling distributions before you can understand how a sampling distribution can be used. And in this series of videos, I'll spend most of the time talking about the idea of a sampling distribution and the concepts that go along with sampling distributions, but also get a little bit into how a sampling distribution can be used. I'll talk about how a sampling distribution can be used to calculate the probability of getting a certain type of sample, and later on in a different series of videos, I'll probably talk about how a sampling distribution is important because you need to calculate the probability of getting a certain type of sample to be able to make a conclusion about a population based on data collected from a sample. When you're first learning about a sampling distribution, the most concrete way to think about it is to think about it as a set of possible outcomes that might be found when you take a sample from a population. And I'll explain what I mean by this. First, we need to talk about the idea that there's more than one possible sample that can be selected from a population. Let's say that I go to a university that has 20,000 students, meaning I go to a university at which the student population at that university includes 20,000 people. And I randomly select 50 out of the 20,000 students in the population to be my sample that I collect data from. And I record the age of each of those 50 people in the sample. And then let's say I calculate the average age of those 50 people that I recruited. That means that I would add up all of the 50 ages that I've recorded, and I would divide the total by 50 to get the average. Now I've only calculated the average age of one possible group of 50 people. There are other different possible groups of 50 people at that university that I might have recruited, and those other possible groups of 50 people would have given me different averages than the average that I calculated with my own sample of 50 people that I happened to recruit when I went to the university. You can think about it this way. If another researcher goes to that university and recruits his or her own group of 50 people, as long as that group of 50 people that the other researcher recruits isn't the same exact group of 50 people that I recruited, meaning as long as there's at least one person in the other researcher sample that isn't in my sample, then the other researcher sample would be considered a different sample of the population than my sample. It would mean that I selected one possible sample of 50 people, and the other researcher selected a different possible sample of 50 people. And if that other researcher calculated the average age of his or her own group of 50 people, the mean of that researcher sample probably wouldn't be the same average as the average of my group of 50 people, as my sample of 50 people. The reason is because that researcher selected different people who might be younger, who might tend to be younger or older than the people in my sample. If the other researcher sample included more older students than my sample, then the mean of that researcher sample would be higher than the mean of my sample. And if the other researcher sample included more younger students than my sample did, then that other researcher sample would have a lower average age than my sample. So there's more than one sample that can be taken from a population, because whenever you recruit a sample of people from a population, there's more than one combination of people that you might end up recruiting, and each possible batch of people that you might select or recruit, meaning each possible sample that you might recruit, will typically give you a different average. Each sample has its own average that it'll give to you. And it's possible that two different possible samples might give you the same average. After all, it's possible that my group of 50 students would have the same average age as the other researchers' sample of 50 students, but it's highly unlikely. It's more likely that that other researchers' sample of 50 people would have an average age that's at least a little bit different than the average of my sample, assuming that the other researcher's sample is a different sample than my sample, and that there's at least some people in the other researcher's sample that aren't the same people that are in my sample. So now we're talking about how the sample mean varies across different possible samples, which means not every possible sample that you might select from a certain population has the same average. And this idea that the sample mean varies across different possible samples is called sample variability. Now imagine if I went to that university where the student population is 20,000 people, and I did record the I did record the age of all 20,000 students. And then after I recorded the ages of all 20,000 students, I take my list of ages and I sort that list out into all possible combinations of 50 students. And then I calculate the average age of each possible combination of 50 people. And then I just write out a list of the average age of all possible combinations. Meaning I write out a list where I say the mean of sample 1 is this number, the mean of sample 2 is this number, the mean of sample 3 is this number, all the way down. And I do this for every possible combination of 50 students. That set of averages that I'm writing out would be called the sampling distribution of the mean. It's the set of the sample means of all possible samples that might be selected. And the reason that it would be called the sampling distribution of the mean is because I'm calculating the mean of every possible combination. If I wrote out all possible combinations of 50 people and I calculated the median of every possible combination, and then I listed out the median of each possible sample of 50 people, then my list would be called the sampling distribution of the median. If I calculated the standard deviation of each possible combination and then wrote out all of those different standard deviations, what I created would be called the sampling distribution of the standard deviation. And when I said that I would create all possible combinations of 50, the number doesn't have to be 50. I could take the 20,000 ages that I've recorded and create all possible combinations of 20, and then calculate the average age of all possible combinations of 20. The only important thing would be that I would have to make each combination the same size, meaning I couldn't write out some of my combinations with 50 people and other combinations with 20 people, and then mix in those different averages together in the same list. When I create that list, every combination that I'm creating has to be the same size. The reason is because if I go to that population and I select 50 people, I'm drawing from all of the possible combinations of 50 that might have been selected. I'm not drawing from any of the possible combinations of 20. So if I want to know all of the possible combinations or samples that I might have selected, when I recruited 50 people, I would have to write out all possible combinations of 50. Now, if I recruited 20 people from the population, then I would be drawing from the possible samples of 20 that might be selected. And in that case, if I wanted to know all of the possible combinations of 20 that I might have selected, I would have to sort out the population into all possible combinations of 20 people. In these videos, I'll be showing you how to create a sampling distribution with a small population. I'll show you how to take that small population and create all possible samples that might be selected from that population. Then I'll show you how to calculate the mean of each possible sample, and then I'll show you how to write out a list that shows the mean of each possible sample. And I'll be referring to that list that shows the mean of each possible sample as the sampling distribution. But technically, the word sampling distribution refers to the shape that that list of sample means has. It technically refers to the shape that you would see if you took that list of sample means and plotted those sample means in a histogram. That's where the word distribution comes from in the term sampling distributions. But I'll be referring to both the list or the set of sample means and the histogram of sample means as a sampling distribution, just to make things more simple. Now, in order to explain the idea of a sampling distribution and visually, and to explain some of the concepts, I'll have to use a really small population. And an example of a really small population could be a family of 4 people. A family of 4 people would be a complete population because it's a complete group of people in which the members have something in common with each other. But it's a population that's a lot smaller than the types of populations that people are usually interested in studying. But we'll just use this population to explain some concepts. Let's say that these are the ages of the 4 people in the family. There's a mom, a dad, a brother, and a sister. Each member of the population has their own data value, which is their own age. Now, what if I was interested in the ages of the people in this family, but for some reason I didn't have enough time to record the ages of all 4 people? I only have enough time to recruit 2 of the 4 people, meaning I only have enough time to collect data from 2 people in this population, which means I'm going to end up recording 2 ages, and those 2 ages will be my data set that I've recorded from my sample. Now, if I take 2 people from this population and record their ages, there are 6 possible samples of 2 people that I might end up selecting. I might end up selecting the mom and the dad to be my sample, which would be one possible combination, or one possible sample. The mom and the brother would be another one, and the mom and the sister would be a third possible sample. Notice at this point how we've already covered all of the possible samples that include the mom. So now we'll switch and we'll start talking about possible samples that include the dad. We've already talked about the sample in which the dad and the mom are together, so let's skip that one. Let's move on to the sample of the dad and the brother. That's a 4th possible sample that we might end up selecting. Also, the dad and the sister is another one. At this point, we don't have any other samples that include the dad because we've covered all of them. So let's move on to the brother. The brother has already been paired with the dad and with the mom, which means that the brother can only be paired with the sister now, and that's the last possible sample. So if I take a random sample of 2 people from this population, or if I just take, in general, if I just take a sample of 2 people from this population, I'm going to definitely end up with one of these 6 possible samples of 2 people. And each possible sample that I might end up selecting will give me a different data set. If I end up selecting the mom and the dad to be my sample, the two data values, meaning the two ages that I'll end up recording, will be 42 and 45, and the average of my sample, or the mean of my sample, will end up being 43.5, because if you add up 42 and 45 and divide the total by 2, you get 43.5. The mom and the brother, if they're my sample, then my data set will end up being 42 and 15, and the average of my sample will be 28.5, because in this case, the two members of my sample have the ages of 42 and 15, and if you add up those two numbers and divide the total by 2, you get 28.5. Now going down, you can see how I've written out the data set of each possible sample, and I've also written out the average or the mean age of each possible sample. And this list right here on the right side, which includes the mean of each possible sample that I might end up selecting, is called the sampling distribution of the mean. These 6 numbers over here make up the sampling distribution of the mean. Now we can look at the population and the sampling distribution side by side. We have the individual people in the population on the left side, and we have each individual person's data value. On the right side, we have the mean of each possible sample of 2 people, and this set of 6 numbers is the sampling distribution. And we know that every possible list of numbers has its own shape that can be seen in the histogram. And this column of numbers over here is a different set of numbers than this column of numbers over here on the right side, which means that if we created a sample with the ages of the individual, if we created a histogram of the ages of these 4 individual people in the population, we'll end up seeing a different shape in the histogram than if we created a histogram of these 6 possible sample means over here. Because since they're different sets of numbers, they're not necessarily going to have the same shape in a histogram. Different sets of numbers have different shapes. Now let's actually create the histogram of the population and the histogram of the sampling distribution just to see what those shapes look like. These are the 4 people in the population. We had 2 people in the population who were between 10 and 19 years old, and we had 2 people in the population who were between 40 and 49 years old, which were the parents. So this would be the histogram of the population, of the individual people in the population. This right here would be a histogram. It would be the histogram of the 6 possible sample means, because we had 1 sample that had a mean between 10 and 19. We had 3 possible samples that had means between 20 and 29. We can see that back here. Sample 2 was 28.5. Sample 5 was 28.5. And sample 3 was 27. So 3 samples had a mean in the 20s. We can also see that 1 sample had a mean in the 30s, and it looks like 1 sample had a mean in the 40s. So we had 1 sample had a mean in the teens, 3 samples had means in the 20s, 1 sample had a mean in the 30s, and 1 sample had a mean in the 40s. Let's see if that's correct. That's correct. You can see that in this histogram. 3 samples had means in the 20s, which is why this goes up to 3. This bar goes up to 1 because one sample had a mean in the 30s. And this bar goes up to 1 because one sample had a mean in the 40s. And in the next video, we'll start to talk about how when we make a sampling distribution with these 4 people, we don't have to create samples of 2 people. We could instead write out all possible samples of 3 people and then create another sampling distribution with those samples of 3 people. Thank you for watching.